I noticed that Visual least actually is doing Java again. You can do Java in it as well as C# and C++ and Visual Basic, and you can create Android. Again, I don't know if that's only on the or all versions of Visual Studio. They have dropped Java. Sue them. You need to. Okay. And it'll be a console project. Make sure it's C# console. I'm going to call it if statement examples. So you guys with me? I'll give you a minute if you're not. Looks like most of you are there. Okay, so let's do a simple if statement. And then actually, I think the second thing I'm going to do, I'm going to redo the homework, not the homework itself, but like the extra, without the if statement, because we haven't done if statements yet. But to really make that work, you need an if statement. So I'll show you how that would work. But first, I'll just do the syntax of a simple if statement. I am going to get an input. So console, write line. And I'm just going to say, enter a number. I don't know. Let's just say enter a number. Let's just leave it really vague. And we'll make it an int. Doesn't have to be an int, but I'm going to make it an int. So I'm going to do number, int number equals int.parse console read line. Are you guys all comfortable with that? Because that's what we were doing on our last assignment. So basically, I'm just going to have them enter a number, and then what we'll do is an if statement, and we'll just check to see something about that number. So the first thing I'm going to do is I'll just do if, and then there's a parentheses. You have a variable that you test. If number is greater than, what do we want to say? Any number, arbitrary. 20? Okay, so if the number is greater than 20, what do we want to do? I'm just going to say
number greater than 20.
Yeah, that's what I'm going to say. It's pretty boring. So there's a couple of things I want to talk about. This is a simple if statement, right? One of the things that, what the if statements, and they're called selection statements, basically. What they do is they allow your program to make a decision based on some value. So we're basing it on number, and we're saying if the number is greater than 20, then we'll do this. If the number is not greater than 20, at this point we're doing nothing, right? It just goes on. Anybody know? So this has to, what's in the parentheses here, has to resolve to a Boolean. Do you guys know what a Boolean is?
True, false.
True, false, right? Yeah, so it has to be something that can be resolved to true or false. So, number greater than 20, that can be said, yes, it's greater than 20, or no, it is not greater than 20, right? So that's a true, false, yes, no. Couple of other things. Notice there's no semicolon here. All right, because this is a block statement. Now, I did the block here with two curly braces. This is the beginning of the if statement. This is the end of the if statement. Within those curly braces are all the lines that are controlled by the if statement, right? You can have a lot in here because you could, if the number was greater than 20, you might have a half a dozen things you want to do, and they can all be in the curly braces of that block. Curly braces mark off blocks of code. When you have curly braces, like for an if statement, then there's no semicolon here. If you do a semicolon here, none do an error. You just won't do anything. The statement before you're doing anything. Couple of other things I will mention. If there is only one command under it, you don't need the curly braces. Although I suggest you always use them because otherwise you'll forget them when you do need them. But there's more than one line of commands in the if, you have to have the curly braces. And it doesn't hurt to always have them.
What does the dot parse do?
Oh, so the dot parse is basically because everything on the console is a string, and we have to convert it to a number. What the parse does, as I said, it removes the quotes from the number and sees if it's a legitimate number. If it is not a legitimate number, it will fail.
Can you still read it as a string and convert it?
It has to be parsed out.
Oh, it has.
If I made this a string, I could then convert it. But it actually would end up being the same thing.
Yeah.
A console. Just pause. We'll run this rather boring little thing. So I'll enter a number, and I will say 20. Here it says your number is greater than 20. I'll show you a couple of other. If I enter a number and it's 16, because I didn't say what to do, right? And again, the else should have braces, so you don't need them if you're. And what I will do is right line, your number is less than 20. Okay. Basic if else. This, if it's not true, do this. So this handles all not true, right? The first one is any number greater than 20, it'll just 20, it'll do the second part. There's one. So if I do 20. How the if works? get you is that every instinct in your body, if you have, want to put a semicolon there. Curly braces. Did a semicolon. It would do this. We are going to, once we get a little bit more on this, but down here you can get your compilers and warnings, and those are a good thing to pay attention to. Like that. Let's do it. Try to run. It's running what worked last time, and it worked successful builds. I'm going to say no, and down here you'll see the little error. you could write it equals false. So I showed you a whole bunch of different operators there that you haven't seen. One is the front of this would mean to say not. So if not, good number. That only works with Booleans, basically. So if not, good number. So if it's not true, then it's false. It assumes true, right? If you don't put a not in front of it, it assumes it's true. This is another thing. Why is this a double equal sign? Does anybody know?
Comparison.
Yeah, the comparison is not do. That's an assignment where you're assigning a value to the very literally can't tell the difference. Are you assigning something, or are you comparing? Compare something. Compare the equality sign. So if good number equals false. So what this will do, and when there's things like you could go back up and let them enter again, but what it will crash now. So I'm going to do 6. Okay, now if I could loop, which is next week, we could go back. It's nice not to crash. It's not.
I also realize
It doesn't read a line.
okay.
And when you do read line, it will, like if you enter multiple characters, like 20 actually would.
I mean, but to end the program, would it make a difference if you use the read line or a read?
Actually, no. Both
Okay.
would pause it.
Okay.
I just rekey and then I can just press and enter and it's done. Yeah. I think read line would behave the same though. So I'm just going to comment up here. This is not equal. And this is equals. Okay. So those are operators we haven't, some of you may have never seen before. Others, I mean, they're pretty common. These are not C# specific. They're pretty much in any, they're in JavaScript, they're in Java, they're in PHP. Yeah, they're pretty well everywhere. They're real common operators. But if you've only done Excel and stuff, you may never have seen them. Questions on those? I showed you triparse, and you can use triparse if you want. It adds a little bit of complexity in that you have to have a variable up here. You have to have a bool. And then it's a triparse. You do the read line and you tell it what variable to assign the value to if it's good. Right, outnumber. So basically it's going to, if it is good, it says, okay, assign that value to number, and then you can use it. If it's false, by the way, it doesn't, it assigns a 0 to the number. So it still assigns it a numeric value, but it gives it a 0.
Is there also a float triparse?
Yes, so it would just be double triparse or float triparse. There's lots of different floats. Almost everything, just like there's a parse on almost everything, there's a triparse on everything. And triparse is probably your better bet just for not crashing the program. When I use parse just by itself, it's usually when it's the machine, the program providing the value, and you can be absolutely sure it's in the right format. You know, when you do user entry is always unreliable. And so you always have to kind of validate it. Okay, so that's another use of the if, and it gives us those other operators. Any questions on ifs right there? I'm going to do another couple things, and then I will do that extra credit thing. And we'll do a couple of exercises. Ifs are not hard, I don't think. Loops are harder. We'll do those, as I said, next week.
You also want to show the and.
Yeah, I was going to show that. So let's do some ands. What do I want to do? I'm going to comment this out for right now. There's a neat little key. I don't know if you can see it. Up in the toolbar, there is a icon that will comment out a whole block at once. That's actually a really nice thing. So it's way up there. And you can also, right next to it is uncomment. So you can uncomment lines if you want to. I'm going to comment them out because although I could probably leave them, it probably doesn't matter that much. We'll see. Between 1 and 19. Although if you want to go to 20, here's another operator you haven't seen. Less than or equal to 20. Have you guys seen that before? Okay, less than or equal to. I'll try to comment all these. And I think there is in the those resources I gave you, there's a document that goes through all of these pretty much. Anybody know what the ampersand and is doing? It's and, right? When you think of Boolean, there's parts of it besides true and false. So basically a Boolean, who's using pens and don't erase? I don't know. So there's true, there's false, and then there's some, basically there's and, or, and not. And that basically makes up Boolean logic. And Boolean logic is actually pretty much at the core of machine language too, what happens in that. So a thing is true or false, yes, no, on, off, right? And then you can combine them. And if you have an and, what is it about an and condition for it to be true? Anybody? They both have to be true, right, for the result to be true. Or only one side of it has to be true, right? And then not so basically negates a value, turns a true false, a false true. So what these are is are and. Couple of things about the and. There's generally I would suggest using the double and. A single and also works. It's called a short circuit operator. I'm never going to test you on this, but does anybody have an idea why it's a short circuit operator? So with a double and, because both sides have to be true for the statement to be true, if this side is false, it doesn't evaluate the second side. That's what short circuits. It's smart enough that it says If this is false, ignore that because it's all false. If you use a single and, it mechanically evaluates both sides even if the statement is false. Does that make sense?
Would that ever be useful?
I don't know. If you really need the second side evaluated for some reason, I don't know. As I said, I always use the double ampersand. Yeah, I can't.
They both have to be true anyway. So
Yeah, I mean,
certainly don't make a difference.
maybe somebody could come up with a reason why you would evaluate the second side, even if the statement was false, but I can't think of
You have
one.
an and combination, so
Yeah, I
it
know.
wouldn't make too much
It doesn't
sense.
make too much sense now. I'm going to, so this is, I'm also going to introduce, we're going to make a block. If greater than 20 and number less than or equal to 50. All right. And then I'm just going to, your number is between 21 and 50. And I'm going to do one more of these just to show a whole block. Greater than 50. A couple other things I want to mention too when I do. And then the last will be an else. Okay, so this, I think I have it all on screen too. This is a if block. So if you need to evaluate all the way down, I think I'm going to show you two variations of this. But this is a block where it basically, whenever it finds a true statement, it stops. Right? So it doesn't necessarily evaluate everything. So it tests this to see if it's true. If it is true, it stops right there. If it's false, it drops to the next one. And then it evaluates that. And if that is true, it stops there. If it's false, it drops to the next one. And then if that is false, it drops to the else. So it gives you a block. It's a way of testing range values. There are ways to do it. You actually don't have to do the ampersands here, but we'll leave it. We'd have to do it a little bit different. We'd have to kind of turn it upside down without the ampersands. We'd have to test for greater than 100 first, and then. All right, I am going to. What?
Are you going to do? You could do that same thing with a case.
You can do a case, and I will do a case. Yeah. But the other thing I was going to, so you could do this without the ampersands because it tests each value. So if you started at 100, it would test that greater than 100. And then it would just work its way down, so you don't have to do the range. Yeah. An error. Yeah, let's take a quick look. Oh, you have to do number. Yeah.
Oh, it's,
Yeah. Here's the thing, and I meant to mention this. You can see that I'm doing the variable and the variable. You can't just say number greater than 50 and less than. So if I take the number out of here, it will give me an error. See the red curly line? The variable has to be on either side of the operator. Like, if it's not, it'll give an error. So every time, if you evaluate multiple things. So one of the things I'm going to do, and this is a little bit weird, but it's actually really useful. I think I want to do it up a little. Over here, I put a little dot here. Anybody know what that does?
Stop.
Yeah, it stops the execution. It's a debugger tool. And it will allow me to step through this so I can show you how it evaluates as it goes through.
How did you do that?
There's a little gray, you can't see the gray here. There's a little gray band on the edge, and I just clicked there.
Oh. Oh.
So I'll show you what that does. And we'll do this at different times because it'll allow us to step through and you can see what's happening. So I'm going to start. And I'm going to enter a number. Anybody have a number you want me to do? What? 12. All right. That'll hit the first if. Let's do something for the middle if. Or something in the middle. Let's do like 45. All right, so when I press enter, okay, so it pops over here. I want to get rid of the diagnostic tools. I'm just going to move them to the side. Now, F11 moves it from statement to statement. Couple of things. If I put the cursor over number, notice it shows me what the value is. Also, it tells you down here what the value is. This is for later when you're trying to, particularly when you're doing a math in a program and it's coming out wrong, you can kind of look and see what are the variables doing at different times. So this says 45. I can also just put the cursor over it and it says 45.
And it says the value of good number is true.
Yeah. So if I do F11, it goes down to another one. Notice that it skipped this. And it skipped it because that was not true. If I do and, well, it's yes. Notice the ampersand. Number greater than 0, number greater equal to 20 is false. When I come down to this, so number is 45, number is 45. When I do that, notice it says that it's true. So when I do F11 now, it goes first to the curly brace, and then to your numbers between 21 and 50. And then F11 and F11. And actually, if we go back to the console, it'll show that it said your numbers between 21 and 50. And then if I press a key, it'll be done. Any questions on that? And then you want to remove those if you don't want to stop there every time. Does that make sense? The if, else if? As I said, you don't have to do the ampersands there, but maybe I'll just leave that for right now. Any questions on if statements in general at this point? Okay. Are you having a problem with that, or?
I think I'm missing something. Oh no, I'm missing the console.
Oh. Now again, the else handles all other conditions. You do not have to have an else. Because basically, if it doesn't meet any of these conditions and you don't have an else, it just ignores the if statements. It goes through and checks them. If they're all false, it just goes on to the next command. The else is there if you want to be able to handle any remaining conditions. Okay. This would be hard to handle with a switch. I'm trying to think of what I'd want to do with this, with the case. I'm going to we'll just get a second number. So what I'm going to do the try parse again. So I'm going to do int number 2. And then, oh, I didn't do a semicolon, that's why it's mad at me. Oh, I don't know. So basically I'm doing a console read line and then I do a comma out number 2. And then we could do kind of like before. In fact, I could copy that line. Later I'll show you, I'm just copying this. And except I need to change it if good number 2 equals false. Does anybody know what the return does there? I forgot to mention that. So I just copied this from above. Later I'll talk to you about why that's a horrible idea. When we talk methods, you would break this into a method and just call the method because you don't want to repeat the code over and over again. Anybody know what the return here does here, though?
It doesn't do anything, though.
It ends the program.
Yeah.
But that's something. So it won't execute any code beyond there. Right? So if it's false, it's going to print this. It's going to pause for a keystroke. And then when you hit the keystroke, it'll be over. It terminates the program at that point. So return is a way of ending the program. Otherwise, it would tell you to enter a good number. And then it would go to the next command and crash because you don't have a good number. Does that make sense? I see some people looking confused at that. So it's only if you go in here. This never is executed, right? Unless it's not a good number. If the number is good, it ignores it. Yeah. And then if it is bad, if it's false, it's not a good number, it will print that, it'll wait construct. Okay. I'm going to have, and if I did this is very press the rekey. So
The line with good number 2 and false that you copied.
yeah.
Did it initially said exclamation or bang? Right?
Oh, well, I had a couple of different versions of it.
Okay. But it made it initially the same. It was originally good number.
It was originally just good number, right? Well, so I did a couple of things.
Okay.
I did equal false. I also did not good number, right? If we want to, we could, so this would have exactly the same effect, just to put that. It's a little less typing, fewer keystrokes, but it may be a little less clear, you know, to the user what's going on. I mean, if you know what's going on, you can figure that out pretty quickly, but it's a little less verbose, a little less self-explanatory. Whereas not equal false or equals false is clearer.
Maybe it's right.
Yeah, so it's a matter of,
Maybe.
yeah. I'll leave it that way though. And then what I'm going to do, I want to show you one other kind of connection. Then I'm going to do a little bit of the thing, and then we're going to do a kind of a peer exercise where I have you do a little bit of an if statement. And then there'll be time, I think, to work on your home, do lab time. All right, so this is another selection tool. And I'm going to switch on number 2. And what you did, this is switches are not quite as flexible as like in the if block. So what I would do is for each, I said to enter a number between 1 and 5, right? So I'm going to do case 1, colon, and then I'm going to do console right line, and I'll just do 1, the word 1. And then I'm going to do a break. Okay. So what this is doing is testing number 2, and if it is equal to 1, cases that the case is that number 2 equals 1, then it'll do this. And you can do that for each, basically case 2 colon console right line 2, and I will do a break there. You have to do a break if you have a command there. But you can do, I'm going to do case 3. Will it let me do case 4 there? Can't type.
You can have it.
I need a space.
No, you don't have to close brackets now.
Well, I don't need a closed bracket for that, I don't think. No, I don't.
No.
The reason why I didn't do it, case I wanted to show you that it is possible to not have. Okay, and then I'm going to do a default. Okay. And I think I have a curly brace at the end of that, right?
At the end of the, yeah, you do.
Yeah. See if I can get that all into screen. I don't know that I can. Well, I'll kind of walk through. So this is another way to make a decision. Where I find these kind of useful is if you're doing menus, again in consoles. And I don't know, in real life, people write consoles mostly for background programs, for services and things. They rarely use them for actual programs. But we will, we're doing that now. But in a you could make a menu where basically you say select your choice of what you want to do, and then you do a switch which selects the menu choice. That's one of the places I find them useful. They're a little less flexible because you can't look for ranges of values. It has to be an exact match, right? Whereas in the if-else if, you can look for ranges of values. So in the switch, it's going to test number 2. If the number is 1, it'll write 1. If it's 2, it'll write 2. This is, sometimes you can do a fall through, so it'll test for 3 and 4. If there's 3, there's no command there, so it'll fall automatically to 4, and 4 is where it'll handle that. So it's possible to do that. I just wanted to show you can do that. You can have what they basically let it fall through a couple of numbers to another number. 5, well, just do 5. The default it's on the default pane that wasn't handled up above. Does that make sense? Kinda. Do you want to walk through like we did before with the, let me run it and then I'll walk through. So we have 2 things in here, so I'm going to start it. So the first number, I'll just do 60. And then it says enter a number between, and so I will do, and it'll say 3 or 4. Again, we're doing stupid stuff in between here, but you could have a whole bunch of programming logic in those cases. So you can determine, typically what I did, like if this was a menu, and we haven't got there yet, but what I do is I would call a method. Right, in the menu you would call a method. Instead of just writing 4 or 5, you can do something like call a method, call another program. You can do all sorts of different things in there. Same in the ifs. I mean, you can, typically you're not just, your decision is making a decision that determines how the program will execute in the future. You're branching the program based on their users. Make sense? So what I'm saying is you wouldn't use these just to write stupid things generally. Questions on the switch. I use the switch a whole lot less than I use ifs, just to let you know. But it can be used. There are times when it's really useful. Yeah.
I'm sorry, can you scroll up just below the
To the beginning of it?
No,
Default.
actually scroll down.
Down
Perfect, thank you.
to the default, yeah.
Yeah, thank you.
So you basically, you don't have to have a default also. If you don't have a default, it's like an if. If the case isn't there, it just ignores it and goes on to the next code. But a default will have, it's like an else, it handles all other conditions. Other questions about this? Does it make sense? If it doesn't, feel free to speak up. These will give you, as I said, that your program now has more flexibility. If nothing else, now you can make it so it doesn't crash if your user enters something bad. That's with the try parse. It also lets you do, make decisions along the way. Questions on this before I want to do one other, yeah. So it could be lack of a colon or semicolon. Oh, okay. Right. Did you declare number 2 then? So notice that I have, I'll show you. Let's go back up. When I declared number 2, notice that there's an int number 2. I think that's what you're missing. Yeah, I don't think you ever declared number 2, and that's why it's complaining. Yeah.
What does try parse do again? I know what regular parse does.
So so it does the same thing as regular parse, except it returns something different.
Okay.
Instead of actually, when you do try parse, all right, it does the same thing with the read line. It removes the quotes and says, is this a legitimate number? But then it does a little bit more. If it is a legitimate number, it returns true here, and it assigns the value of that number to the variable that you list here with the out parameter. So that variable is up here, right? So this is the same as this. It takes the value, the number value that it parsed out, and it assigns it to this variable.
So if you were to type out like SIX, what would it do?
It would say
It's not even
false,
Okay.
and it would assign a 0 to this.
Okay.
And then we did an if statement, said that if it is false, then it says, please enter a good
Okay.
number. Yeah. Now, if you don't have this if statement, it just returns false here, and then goes on to the rest of the program. Does that make sense? Yeah. So you usually want to handle the false, because the fact that it returned, you still won't get an error because it did assign an integer value to this. It assigned to 0. So it is a legitimate integer at that point. It keeps you from crashing, at least in this instance. So it keeps you from crashing. Last thing on this. So this one we've handled with not equal. I mean equals. I'm going to do 5. And it still says, please enter a good number. I just wanted to demo that putting the not good number there is exactly the same as equals. I'm going to do one of this, but I think I'm going to do a new program. I will post this to the blog, okay? But I'm going to start a new program, and we'll do the talk through the extra credit thing that we were doing with the buses. And then I have a little bit of a quick and peer exercise, and then open lab. If we need, we can have some open lab, whatever day is next, Thursday. I lose track of days early in the quarter in the year. So, any other questions before I move on? One of the things I'll do before I post this on the blog is I'll try to comment it a little too. All right, so I'm going to do, the fact that this has run, means it's saved. If you're uncomfortable with that, you can always do File, Save All. One thing I want to suggest not doing is Save As, because what that actually is doing is it's like exporting it. It's not part of the project anymore. If you save the file, it's just a C# file without a project. If you do Save As, it doesn't save the whole project, it just saves the file. So basically what you want to do is Save All if you want the whole project. File management with this can get really weird and difficult because there's a lot of files that are generated. The C# one is really the only, this program file is the only one we need right now, but if you want the whole project, you need to Save All. Anyway, I'm going to just do a File, New Project, Console App, and I'm going to do like the extra credit. I'll just call it extra credit. And most of you tried it, not everybody, but most of you. And I was pretty forgiving because the best way to do it is with an if statement. Do you guys remember what it was? Basically determine how many buses you need. And each bus has a capacity, I said, of 45?
Yes.
Okay. So one of the things that I'm going to show you, which I meant to show you a long time ago, is if you want, you can do int const. I'm going to call it capacity equals 45. Now, what is it not like? Is it constant? Okay. I just had them backwards. So anybody know what the const does?
Stays that value.
Yeah, it makes it a constant. It means you cannot change this value. If you try to change it in the process of the program, it will give you an error. Right? So it's a variable means that the value can vary, right? It can change. But a const means that it cannot change. The naming convention for constants is all caps. I mean, it works fine if you don't do it as all caps, but the naming convention is all caps. The other thing with a constant is you have to assign it a value at the time you declare it. You can't make it a constant, not give it a value at the same moment you declare it. So we have a capacity of 45. Questions on that? Consts are good. I mean, like if you're doing a program for circles, you could do const pi equals and whatever pi will equal for your program. If you're doing like a conversion of Fahrenheit to, I mean, you could do, there might be some constants you could put in there. I'm trying to think of what it would be. One of the advantages of doing it like this, rather than just typing 45 into the program, is that it has a variable. Did I spell capacity wrong? That looks wrong.
Right.
It is right. It just looks wrong. It has a word with it. It's more readable. There's a thing that's called magic numbers. When you write a program and you just say divide by 45, then people say, well, where in the heck did that come from? You know, where did 45 come from? What does that mean? That's a magic number. So it's always good to label things, and constants are a good way to label things for values that don't change. Even if they do change, you might want to declare them as a variable so that, so that they have some word value, so that it's a little clearer where they come from. All right, so basically what we want to do is I'm just going to get a console. So a read line or a console write line. And we'll just get how many people are on the bus, right? Or
Need to write.
need to ride, or yeah, whatever you want.
I could enter the number of a total students.
That would be fine. That's probably better. And then I'll declare it up here that you don't have to. I'm going to do int students. And then down here I will say students equals, should we do a triparse?
I say.
So if I do, so it won't work if I do that. I need to do like a bool.
Mine is I can it right inside.
You don't have to use a triparse here, but it'll keep it from crashing. And then comma out students. And then you would want to do that if not good number. Add some writing, add some codes to your thing. The read key here is because in Visual Studio, it will, if I put the return here, you wouldn't have time to read this before it quit. All right, so that's just in case it's a bad number. Now, what do you do with the numbers? So we need to basically, I'm going to do int buses.
Students divided by capacity.
Right. So I'm going to do it up here. I'm going to do all my variables up here. You don't have to do that, but int buses. And I'm also going to, so I'm going to do buses equals students divided by capacity. All right. Now, this is an integer division. Remember that? So it will ignore any leftovers, but you can't do that with people. So I am going to say underneath there, and this is the part, so I'm going to say if students modulus capacity greater than 0. Okay, so that's a Boolean. If the result, if the remainder is greater than 0, yeah, we're going to add one more bus. There's a couple of ways you could do this. I'm showing you lots of new operators. That's one way you can do it. Plus equal. Well, plus plus would work also because it increments by 1. Or you could, what this is the equivalent of is buses equal buses plus 1. So if you want a shortcut for that, you can just do plus equal. What?
Quotient plus. The sum equal quotient plus.
Well, you could. I mean, but I'm doing buses as the result of what you have for quotient.
Yeah.
All right. So buses is the students divided by capacity. If the remainder is greater than 0, then add 1. And the plus equal means buses equals buses plus 1. So there's also, let's do a comment here. Okay, so you could also do another operator. I'm showing you lots of operators.
Would most people just do the plus?
You could do the plus plus either way.
I'm a maintenance person. So I typed it out. It's easier to read.
It might be easier to read this one, right? Plus plus is pretty. I mean, it just increments by 1, which it would work perfectly well. And this one would also work. This is really good in loops when you want to keep accumulating a sum or something. So you keep adding to the current number, so it works really well for that. So let's do, then the last part of this would just be the output. Does that make sense? So we're dividing the buses. We're looking to see if there's any remainder, because if there's any remainder, we're going to need another bus, or either that or we have to tell people to stay home. And then basically we just output that. So when you're testing something like this, 5, I'm going to 45. If I had 450, that would come out even to 10. So let's do 458, and it should come out to 11 buses. And it does, right? So you need 11 buses. When we get a little bit more sophisticated, I'm going to talk about testing your code and testing the equations. And part of it is getting values that you can work out in your head and making sure that the answer matches. Are there questions on that? I mean, if statements, as I said, can help you with everything. You look like there might be questions.
I don't know. I'm getting some errors.
Oh, let me look. Okay. And they went away. Buses equal one. Buses equal students. You know what I think it is? You can declare buses. So look at, what I did is, because I declared all the variables up at the top,
Yeah, that's what I was gonna say.
I did int buses.
Where is that? Underneath.
Right. So if you don't declare a variable and just use it, it'll have a red squiggly line under it.
Sorry, I have no question, but I had done like this. I'm gonna submit to you with the.
It should be fine. If you did if you did the extra credit without an if statement, it's fine. I gave you the points. We hadn't done if statements yet. So all I was really looking for was the integer division and the remainder.
How different because I don't use that.
Yeah, we're gonna do that in a moment. All right. Are we, so I will post this also, even though it was an assignment, sort of. All right, so we just had a question about a peer assignment. I wanted you guys to do a little bit of a practice on your own, just other than just watching me. And again, this is one you can't get it wrong. You get points for just being here. But I want you to kind of look at it. Let me get into Canvas. I should have had this up beforehand. So I did a peer assignment. Let me go to assignments. And again, when we're done with this, we'll talk about it. You can do your answer. And if one of you posts the answer, the other can just say, I helped. Whatever you want. This is basically, and this is much simpler than you might think it is. How do you determine? Takes an if statement. You'll be using integers, not doubles. How do you determine or odd? Yeah, well, so what I want you to do is to do it in pairs. So, and then we'll talk about it. So 2, 2, 2. I guess you 2, I guess you 3. Write the program. One of you write the program. I guess you 2 can work together. You 2, you 3.
I can't get on, so you can try.
Why?
I'm a good
Okay.
I can write. Okay.
Okay, I can type it.
Okay.
So somebody type it in. Only one person really has to type it in. And we'll talk about it in like
Let me see
5
the
10 minutes.
name. What's the name? You are exercise two, right?
Yeah.
And then,
Let's see. Okay, so maybe we'll do this. Just we'll start off with it.
and then close the I had.
I mean, it depends on how, you know, fancy you want to make it. You can make this very, use a good road trip.
So basically what we're doing is up here and just going on the side.
Okay, so we can start out when you do a constant right line. Constant right line and say enter a number.
And then
Yes,
Enter a number.
enter a number.
how it started, then we know that it's gonna be even because we're using integers.
Missing some.
So if we divide by two, let's say,
Common.
we divide by two, it's 1.5.
Well, we could the number.
Then it wouldn't equal 3.
Determine.
Yeah, just like determine whether
Equal 2.5.
number is out of even.
It's kind of how it's set up. Enter the number. So now it's 2 divided by 2.